Okay, so welcome back from the short break. My name is Andreas Faath from VDMA Frankfurt, the headquarters of the VDMA, and I will explain you in the next 30 minutes what the VDMA, what we are doing regarding OPC UA Companion Specifications, and I will show you some brief impressions of some of our working groups, and after this, well, I'm open for questions. Well, at first, the VDMA, for those of you who don't know the VDMA is association for industrial machine manufacturers, and it's in Germany and it's in Europe also. And we are representing over 3,200 member companies. So it's not people, it's companies which are from Germany and also over Germany spread. And yeah, we are structured in 38 trade associations. That means, for example, that we got one association for robotics, one for plastic rubber machinery, one for tooling machineries, and so on. So we got 38 of those trade associations, which are all working together in the VDMA. And we got 6 regional subsidiarities. So that means that we have local people spread over Germany, and also we got those international offices like in Berlin, Brussels, Brazil, China, India, Japan, Russia, and Austria. So this is why we're really working internationally, worldwide, and try to support the German and Europe manufacturers in their markets. In addition, and this is where I come from right now, we got working groups and forums. And forum, so I'm from the forum Industry 4.0, that means topics which are not directly related or linked to only one of those trade associations are handled in forums. So those forums are working horizontally over all of the trade associations for topics like Industry 4.0, which are more general and important for the whole manufacturing industry. And yeah, of course, in addition, we got some departments and competence centers, and also some more companies and foundations, but that's just on the side. And what is really important, we are representing a broad machine building and manufacturing industry. So with those 3,200 member companies, we are covering a wide range of the market in this field in Germany and Europe. And to give you an impression how those trade associations look like, I got this slide. So you see here from agricultural machinery right down to woodworking machinery, we got really a lot of trade associations covering one or two special branches in the industry. And I'm pretty sure that you will find yourself somewhere in here if you are involved in the manufacturing industry. So why is OPC UA so important for us at the VDMA? Well, at first, we more and more get the idea from the industry that it is really important that we do integration, and this is in networks, which we have seen already, of components, machines, plants, and systems, and that all is interoperable. So what we are doing right now is doing those companion specifications, hosting those working groups, and try to get those administration shells, the companion specification as part of the administration shell, done with our members, with their expertise on their branches, on their topics. And that is what we're doing in those companion specifications named information models right here, where we have a vendor-independent description of components, machines, as in those standardized information models. And the benefits, well, it's clear, it's on the hand, is the reducing of integration costs, for example, and it saves time and money, and of course it enables new business models. like in the Industry 4.0 is always announced. So this is really where we are in right here, and how we are working right now with the OPC Foundation. Well, for us it's really important that the OPC Foundation is also an independent organization, because the VDMA is also kind of a representative of a lot of manufacturers, where all have the right to give out the information what they want to do the VDMA. So real trying to cover a lot of manufacturing industry, to cover a lot of ideas, and we are not representing only one idea of one of our members. It's all somehow in common of our members there. And this is the same thing the OPC Foundation in our idea is doing, so it's independently, and it's this is really important for us. And how we work together with them is, well, at first, this also refers to the RAMI 4.0 model we have seen in the morning. So the information layer and the communication layer, as you remember, there were an asset integration layer on the bottom, then there was a communication on top of the information layer, and then we have the functional and business layer. So we are right now in the two layers in the middle, communication layer and information layer. So on the communication layer, there's really OPC UA as a technology with the OPC UA meta model. And then on the information layer, we have this companion specifications right here. And yeah, the OPC Foundation covers the both bottom topics, and we at the VDMA, we are doing the companion information models. What we are not doing, and what we are not, we will not do this, is going somehow in this vendor-specific extensions, because this is the extension of our companion specifications where we just put in the information which are, well, used in all of our members in these groups. So really the topics, the variables, the information which is important for only one or two members in those groups, which have also market impact, is not in this companion specification. We are just doing the common basis information which should be standardized and should be exchanged over OPC UA with those companion information models. So how we are working together with the OPC Foundation, who is defining how, and the VDMA is defining in the companion specification what should be transferred, is the OPC Foundation, as I said, defines the OPC UA, and OPC UA uses those companion specifications. And those companion specifications, for example, are developed of working groups belonging to one of those trade associations. So there, for example, there is one working group in the trade association Robotics, and there's, for example, another working group in the trade association of weighing technologies. So the trade associations, the 38 trade associations, some of them have launched working groups to do companion specifications, and those working groups are organized, and we give them a kind of process, a milestones. This is done by the Forum Industry 4.0, where I am doing the central coordination. Well, for that, the VDMA, as I said, hosts those working groups, and the OPC Foundation, and this is important for us, accept those working groups, because we are doing joint working groups together with the OPC Foundation. That means all of our working groups are really trying to have an international accepted and used standard with this companion specification. We want to make it open. We don't want to have a German standard or something like that. We really want to have international use standards, and this is one of the reasons why we are doing all of our companion specifications joined with the OPC Foundation and their members. So what that means, internationally used, well, of course, we get our headquarters in Germany, but as I said, we have one international office in India and China and Japan and Russia, the European office in Brussels, and also Brazil and Austria is coming. And it is really important for us that also you in Finland, if you see that in Germany, the VDMA, there's a working group working on a companion specification, and you think you are or you will use this companion specification or want to join them or want to give them advice or somehow to interact with them, just get in touch with us. We are always trying to make our companion specification as accepted as possible, and that means that you are also able to give us your idea how the companion specification should be designed or which variables or so on should be in there. So just get in touch with us and get informed, participate in there, and of course if you see those companion specifications are on the market, use them, because as I said, it's not a German standard, it's companion specifications done together with the OPC Foundation, so it's an international OPC companion specification standards. Well, right now I'm coming to the core of my presentation right now. So the overview about our working groups. So what I will show you right now is at first how we are structured kind of way with the OPC UA topic, and then go more in detail after a short video which working groups are actually in the development phase and which working groups have release candidates or releases on the market. So at first, you see right here on the left side, we got our internal topics, and on the right side we got our external topic. That means that kind of member supports, for example, in fairs or events and demonstrators we are doing. And in addition, we have a kind of industry advisory council. That means we get our information, our trends, what we have to look on and where we have to go. Ideas of that we get from this industry advisory council, who is talking with us and staying closely with us to get the ideas which are right now on the market. So this is our connection to the market, to the developments which are really here happening on the markets. And in addition, we got those external committees and the coordinations, for example, with the OPC Foundation or the LNI 4.0, the Industry 4.0 platform, the Z4E, another association in Germany, or for example, the Standardization Council Industry 4.0. So these are just examples, there are a lot more, but really, we really try to get connected to the whole community regarding Industry 4.0 and OPC UA. And on the left side, and there just will be here today, our working group. So what we're doing really is a central coordination. So we have a process where all our working groups are following to. We have a kind of quality insurance because we have meeting with our working groups internally in the VDMA, where all of them can talk to each other and discuss their approaches. And of course, we try really to assurance the coherence between those different working groups, that one working group, for example, names tool number, like another working group is naming the same thing, also tool number, and not, for example, tool ID. So interoperability between the different companion specifications is also really important for us. What I will show you right now is a short summary how we in the VDMA see OPC UA and the companion specifications regarding Industry 4.0, and that will be a short video I will show you right now, and hopefully it works.
Together with mechanical engineering companies, the VDMA is developing OPC UA Companion Specifications. Why? Open Platform Communication Unified Architecture, or OPC UA for short, allows engineers a platform-independent, interoperable, and vendor-independent integration of different machines in production. The VDMA represents more than 3,200 member companies and is the voice of the mechanical engineering industry in Germany and Europe. The VDMA supports manufacturers in developing OPC UA Companion Specifications. This ensures smooth Industry 4.0 communication. Industry 4.0 communication is ensured both between machines and from machines to other systems. This leads to more efficient production. For engineers, this results in the Industry 4.0 application fields of plug and work, condition monitoring, predictive maintenance, and OEE improvement. OPC UA Companion Specifications define the form in which the machines provide certain information. This makes integrating the machines into an existing production environment and configuring machines much easier, of course, and it makes the engineer's work much more efficient. That's how Industry 4.0 works.
So yeah, this video just summarizes how we see Industry 4.0 OPC UA and Companion Specifications. And this slide is pretty new. You're the first people seeing this. We are right now developing a homepage called opcua.vdma.org, where we first time give an early access or information to our working groups. So what you see is that each working group which we have in the VDMA will have here its own article where you can see right from the beginning which working groups are right now developing companion specifications, which companies are involved, what machine types they will cover in their companion specification, what are their use cases, what are the scope, what are the purposes, do they have demonstrators, do they have fair booth or something like that. So this is really the new site. It's under preparation, so you can go on this, but it's not finally online. And you can see and get really early access to information of our working groups way before they are announced, for example, on the international or national presentations. And in addition, on top right here, we also got news where the newest activities in regarding OPC UA are presented, and there will, for example, also be announcements of demonstrators and so on. So this is the one side, and in addition, on this homepage, there will be the possibility to download the companion specifications done in the VDMA, and the difference between the OPC Foundation homepage, where you also can download the companion specifications, is that here you also can download the specifications as drafts. So it's not the release, which is already released and not changeable. There, the release candidates, so the drafts will be available for download. And do that, you can get in contact with the working group and give recommendation or advices or ideas on the drafts which are downloadable right here. So before it's released and still changeable. So right here you see the overview of our OPC UA Companion Specification working groups. And what is really important is that the blue ones are the working groups which have companion specification under development. And it's really interesting because what is kind of impressive is that about 90% of those blue ones started beginning or mid 2018. So in this year we have about 5 to 10 working groups really starting doing OPC UA companion specifications in the VDMA. So this is a huge number for us, and there will be following working groups in the end of the year and starting next year. So what I will show you the next slides are the ideas and short content of the ones of machine tooling, manufacturing systems, of machine vision, plastic and rubber machinery, and also robotics. And those working groups are the working groups who have at least release candidates or releases on the market and are in a late development phase of their companion specifications. So those also are those working groups who started first, for example, in 2014. This is for plastic and rubber machinery. So there are two specifications on the market. At first, it's a Euromap 83 and the Euromap 77. Don't get confused about this Euromap in front of it. Euromap is a kind of more international association where the VDMA is involved. But they are doing this under Euromap because there they not get only the VDMA members, but also the Euromap members involved. And they have the 83, which is kind of a basis companion specification with general types, which are then used later in the more specific companion specifications, like in Euromap 77, which aims on injection molding machines and the connection to MES or central computers, so vertical integration to systems. This is already released. Then we have a release candidate, which is 82.1. So what that means, 82 stands for peripheral devices. I will show right now in a minute. And this is aiming on injection molding machine again to temperature control devices. And what is under development? Under development is the Euromap 79, so injection molding machines to robots, and the Euromap 84 extruders to MES. And they are planned Euromaps 82.x, so extensions or following specifications to this, which are more peripheral devices connected to the injection molding machine. So what you can see right here is they really started focusing on injection molding machines. They said firstly, we have to connect them to higher systems, vertical integration to MES. The same thing they are doing extruders. And right now they are really trying to get more communication partners covered in their companion specifications, at first regarding to the injection molding machine. The Euromap 77, just to get the idea who's behind that. Well, you have here really the machine manufacturers, you can say here. Then they have also controller manufacturers in there, so it's not just the machine manufacturers, it's also the controller manufacturers or controller companies are involved. Then we got a lot of MES suppliers. Well, this is because it's injection molding machine to MES systems. There are MES suppliers in there. And this is really important, they also have one user, Lego Systems. So Lego Systems really was powerful here and said, okay, let's join this, let's do that. So this is the working group really who's behind this Euromap 77 injection molding machine to MES. So you see, it's really, they reach a critical mass of companies standing behind it, developing it, and hopefully use it now and in future. To make clear how the Euromap 83 and 77 works together. In the Euromap 77, for example, they are defining this part on the information model. And if we look, for example, at the machine information type or here the machine configuration type, it's important that those are not specially for this injection molding MES companion specifications. Those standard parts are important for all of their companion specifications, or at least most of them. So they are putting them in the 83. So all of the, I would say, more common general information is put in the 83, and this is then referenced and nested in later on coming Euromaps and companion specifications. Next thing I promised is about tooling, machine tools. They named it, as you see here, UMATI, Universal Machine Tool Interface. And what they are doing is they try to get one companion specification which covers the need to connect machines to also vertical systems, to define standardized interface, and to get it in touch, to get it connected with higher systems on or outside of the shop floor. So they are not concentrating only on shop floor communication, but also outside the shop floor. And they're trying to get first a basic description of tooling machines, which all have in common. Then they want, for example, status and OE, so overall efficiency monitoring. And like tool management, automation system interaction, or order management is foreseen. So a lot of use cases are in this companion specification UMATI. Who's behind it? Again, on the right side, you see here, it's 10 machine tool manufacturers, it's 5 controller suppliers, and it's 1 research institute who is supporting the working group. And they really try to get it done for the whole world, not just for German market, but for the whole world. Next thing is the Vision Initiative, so the Vision Group. They started 2 years ago, and they have a co-working group with 10 companies and had a total working group with at least 60 companies, so really a lot of companies are also behind it here. And they had about 19 days of face-to-face meetings, so normally 2 days meeting. Yeah, they were really powerful on this specification. And one thing they mentioned is that they always get the sentence, the camera is not working, but the camera is not working is not fitting to vision systems, because a vision system is not a camera. A camera just transforms physical things in electrical signals, and the vision system also gets these physical quantities, but it puts it in information. So this is the really important difference between a camera and a vision system. There is information as an output, which you can use in your processes or whatever. And what is important there, they are really different from each other. So you cannot say there is a typical vision system and it's always looked like that. It's dependent on software, for example, which is also very different. And this is why they decided to don't describe the vision system in the companion specification component oriented, but more oriented on behavior and management of data. So what they have all in common is they defined is configuration of data management or receipt data management. So they are defining how those containers, which they don't describe deeply, are getting in the vision system and how the results are getting out of the vision system. So this is what they all have in common, but what is in those containers getting in and out of the system, the byte blobs or whatever, are not really defined here. And the second one, as I said, is the behavior of those of those vision systems. So behavior is also the same thing for the vision systems. So here you see this kind of state machine. So this is a first level state machine which is mandatory defined in this companion specification, and it's for the behavior. And there, for example, it's the halted error management, the pre-operational state, the operational state, and also how you get from one to another state is defined right here in this companion specification. And below of each of the states are more status machines in this companion specifications, but they are not mandatory at all, they are optional. But if you have a deeper standard or a deeper state machine and you want to implement it, there are at least a standardized way in this companion specification. The next one, and that's the last one right here, is a Robotics Initiative. So the Robotics Initiative on the right side, again, you see who's behind it. And they also have a release candidate, which you can download right now. And they had 9 face-to-face meetings with a co-working group, and about 35 companies are in the total working group. So also, like the vision system guys, they have a co-working group and a total working group. And what is really interesting here is that they had a demonstrator on the Automatica fair, which I will show you later. Well, what have they done? They said a robot, if you imagine right now about a robot, well, I think you will have 3 axes, you will maybe have 6 axes, somebody else got 5 axes in his mind for a robot. So how can you define a typical robot? The way you can do it is that you think, okay, we will do this component-oriented, and that means we are saying it is a motion device system. It's not a robot, but it's a device system which is doing motions, so motion device system. And this motion device system contains of different components, and those components on this motion device is described in this companion specification. So they said there are 1-to-n motion devices kinematics, there are 1-to-n axes in it, there are 1-to-n controllers in it, and so on. And you now can build your physically, your physical robot out of the specification, because the specification is available for, or parts of the specification, object types of the specification are representing different parts, different components of your robot. So right now in the part 1, they are trying to get asset management, condition monitoring, so more getting data out of the system. And later on in subsequent parts, they also will try to use methods and state machines to have alarms and conditions, and to get more also data from the outside in the robot, in the motion device system. And this is the overview of this demonstrator I announced already. This was on the Automatica Fair in the summer. And there you can see that ABB, Engel, Keba, Klaus Maffei, KUKA, Mitsubishi Electric, Siemens and Yaskawa had over Microsoft Azure Cloud using the OPC UA Companion Specification for robotics. One display, one interface here where you can see data, live data of robots really working on this fair at one place, and you have access to this robot. So this is demonstrated on the fair, but of course you can do this for all robots you have all over the world if you put them over the specification into this Azure Cloud, for example. And this is how it looks like. So we had here the two displays where here was running the interface, and you could really switch from one robot to the other robot located on this fair. And yeah, as you see, it was really crowded. A lot of people wants to get involved there, wants to see how this demonstrator works. And well, I was told that the integration of the OPC Companion Specification and the integration of the robot into this demonstrator was about 20 minutes to get the specification on the robot and just working. So pretty fast. And well, yeah, to get to an end and to put it in a nutshell, it's like the VDMA represents a broad range of manufacturers of the industry. We are get told that OPC UA is really important. It's right now the momentum to get starting the companion specification. So this is why a lot of our trade associations are starting working groups doing companion specifications. We are working closely to the OPC Foundation to get not German standards, but internationally accepted standards. So this is the invitation to get in touch with us if you have some recommendations or something else. And right now, about over 50% of our trade associations are at least informed. And this year, about 5 to 10 working groups started doing companion specifications and are really working toughly on the development. So the key message, as I said, companion specifications for the manufacturing industry is done in the VDMA. And if you have questions or want to get involved in some way, please just contact us or give me right now some questions. Thank you.